What if the train stations of the late 19th century were never meant for steam at all? What if the engines of 1890, those symbols of coal, iron, and smoke, were merely stand-ins for a technology older, cleaner, and far more advanced than anything the Industrial Revolution could claim credit for? The thought lingers like dust suspended in a quiet hall, unsettling in its simplicity. We may have mistaken the ruins of a forgotten civilization for the inventions of our own. We begin in 1890, a year the history books describe as the height of mechanical ingenuity, when the rail networks of the world were roaring across continents and empires. Steam was the king of motion. Coal was the heartbeat of progress. That is the narrative we are expected to believe. Yet, as we trace the surviving train stations attributed to a so-called lost empire, Tartaria, we find structures that do not behave like children of the industrial age. They stand too clean, too deliberate, too impossibly refined to match the hurried grit of 19th century manufacturing. And beneath their marble floors and vaulted halls, shadows of a different story begin to form. Channels of water, subterranean chambers, copper grids, and arcs of architectural symmetry, so precise they resemble circuitry rather than masonry. Imagine walking into one of these stations at dusk. St. Petersburg, Moscow, Samarkand, Chicago, Budapest. Imagine how the evening light spills across stone polished to a mirror-like sheen. There is no soot staining the ceilings, no black residue clinging to the cornices, no evidence of the choking factories that allegedly birthed them. Instead, the interiors feel almost ceremonial, like temples disguised as transport hubs, built with a degree of craftsmanship wholly inconsistent with the frantic expansion of 1800s industry. The walls do not simply hold weight, they conduct it. The columns do not merely rise, they resonate, as if once designed to catch flows of energy rather than passengers rushing for trains. It is here, in the stillness between documented history and architectural fact, that the central mystery emerges. These stations do not look like products of coal and steam. They look like instruments, precise, harmonic, and interconnected. And the deeper we look, the more this impression grows. The forgotten water-powered rail networks of Tartaria, if such a thing existed, would explain the otherwise inexplicable. But to propose that now, at the very beginning of this investigation, would be premature. For the moment, we simply acknowledge the contradiction. The industrial world of the 19th century could not have created structures like these with the tools it claimed to possess. Search engines today are filled with terms like Tartaria, mudflood, lost technology, hidden history, and water-powered rail system, each attempting to stitch together fragments of a past that refused to vanish quietly. People ask why so many buildings of the 1800s resemble relics of a forgotten empire. They ask why the most monumental structures, including rail stations, look older than the societies that occupy them. They ask why documentation is missing, why blueprints contradict themselves, and why photographs show technologies that do not align with the narrative we inherited. And while mainstream academics dismiss such questions as conspiracy or misunderstanding, the buildings themselves stand mute, yet undeniable, unchanged, unburned, unblackened, and uncooperative with the official story. Consider the shape of the arches inside these stations. Perfect, repeating, mathematically harmonious. They echo the geometry of resonance chambers. Consider the abundance of copper embedded throughout the walls and ceilings. Not decorative, but arranged in looping patterns like conductive pathways. Consider the water channels found beneath certain stations, tunnels that do not align with ordinary drainage, but follow the logic of controlled hydraulic flow. Consider finally the rail cars, photographed in the 1870s and 1880s with no visible coal compartments, steam valves, or soot exhaust. If these were indeed steam-powered machines, they lack the basic features that steam power requires. The inconsistencies pile up quietly, like grains of sand slowly burying a clock. Of course, none of this proves anything on its own. A mystery is not solved by its fragments. But in each anomaly, we sense an echo of a civilization that may have known how to bend water, pressure, acoustics, and conductive metals into a unified system of motion. Still, we resist the urge to leap ahead. For now, we simply look, we observe, we acknowledge the mismatch between narrative and artifact. And we admit that Tartaria may not be a myth, but an unspoken chapter of humanity's technical adolescence, one that ended abruptly, perhaps violently, leaving only stone and silence behind. The official history of 1890 tells us that coal stations were dirty, loud, and industrial. But these Tartarian stations are none of those things. Their surfaces are immaculate, their forms elegant, their patterns intentional beyond mere practicality. They are too large for the needs of their day, too sophisticated for their supposed builders, and too consistent across continents to be coincidences. The fact that structures separated by thousands of kilometers share identical measurements and stylistic DNA should unsettle any historian claiming local construction trends. This is the work of a unified architectural language, one that predates the industrial states occupying those lands in the 19th century. Even the foundations raise questions. When modern engineers excavate beneath these stations, they often find older layers, stone blocks cut with techniques lost to modern tools, channels carved with uncanny precision, and cavities that appear designed to hold or direct water under pressure. In some cases, the subterranean structures are older than the cities built above them. And yet, these are labeled as basements, storage rooms, or pre-existing foundations, though no official record exists to explain who built them or why. We should not accept the idea that such construction was accidental or decorative. Architecture this deliberate serves a purpose, but the purpose has been obscured by time, disaster, and perhaps deliberate rewriting. Mudflood legends, found worldwide in the mid to late 1800s, speak of cities buried suddenly, of technologies lost under layers of silt, of empires erased by a catastrophe nobody agreed to describe clearly. It is only through modern rediscovery, through old photographs, abandoned maps, and structural inconsistencies, that we begin to see what these stations truly represent. The question becomes unavoidable. If these stations were not built for steam, then what were they built for? If their foundations hide complex water channels, if their walls whisper the language of resonance and pressure, and if their global consistency implies a single architectural intelligence, then the official narrative is incomplete at best, deceptive at worst. Something is missing, something big. And the only way to understand it is to continue digging deeper into the anomalies, the timelines, and the evidence scattered across continents. Because the strangest clue of all, the one that redefines the entire investigation, has not yet been revealed. And it lies not in what we see above ground, but in what flows quietly beneath our feet. To understand how strange Tartarian train stations truly are, we must first revisit the world they were supposedly born into. History insists that by the late 19th century, humanity had already chosen its path. Coal was the engine of empire. Steam was the skeleton that carried nations forward. Rail networks were expanding with unprecedented speed, weaving across continents like iron veins, delivering the lifeblood of industrial progress. The story is simple, linear, and reassuring, almost too reassuring. Everything, we are told, fits neatly into the narrative of invention, competition, and mechanical evolution. But when we place that narrative beside the physical evidence of Tartarian architecture, the confidence of the official account begins to tremble. The accepted timeline of rail development claims that by 1869, with the completion of the American Transcontinental Railroad, the age of steam had reached maturity. Europe followed similar trajectories. Britain's rail boom accelerated through the 1840s. Germany's small lines unified into vast systems by the 1870s. And Russia's grand expansion culminated with the partial operation of the Trans-Siberian Railway by 1891. These milestones define the industrial world's proudest achievements. And yet, something doesn't align. The train stations associated with Tartarian design, those built or heavily renovated between 1850 and 1890, do not match the tools, materials, or construction habits of the societies that supposedly created them. Official documentation describes the sweating labor of thousands of workers hauling brick, timber, and iron into place. But Tartarian stations reveal a level of precision that would require advanced measuring instruments, uniform casting techniques, stone cutting technology, and metallurgical knowledge that was unavailable, or at least undocumented, in the mid-19th century. The narrative becomes strained the moment one looks closely. How could nations struggling with basic infrastructure erect palatial stations with marble vaults, polished granite floors, and towering arches executed with mathematical perfection? How could builders simultaneously produce soot-choked factories and immaculate train halls free of the grime and chaos that defined heavy industry? The contrast is too sharp to ignore, and it creates the first fractures in the canonical timeline. Official histories describe these structures as triumphs of craftsmanship. They call them masterpieces of the architectural revival. But this explanation carries a subtle assumption that 19th century builders had the luxury of time and resources to pursue beauty over function, that they did so across multiple continents, that they borrowed from the same hidden textbook of geometry, proportion, and symbolic design, that identical motifs emerged spontaneously from distant cultures without communication or shared technology. Such coincidences stretch belief. They imply a world more interconnected and more technologically sophisticated than the textbooks dare to admit. We are also told that these stations were built for the strict functionality of steam-powered transport. Coal was the pulse that kept the world moving. Every rail hub required storage areas for fuel, soot vents, ash pits, and maintenance workshops suited for heavy industrial work. Yet many Tartarian stations lack accompanying coal facilities entirely. Their walls bear no scars of vented smoke, no blackened surfaces from decades of burning fuel, no char that would accumulate inevitably from engines constantly entering and exiting their halls. Instead, these buildings display tranquility, geometric harmony, acoustic balance, and an almost spiritual cleanliness, as if soot had never touched them at all. How can one reconcile the calm symmetry of these interiors with the choking industry they were supposedly built to serve? The official record strains further when we examine the foundations beneath several of these stations. Historical maps rarely mark what lies underground, but excavation reports, often buried in municipal archives, reveal older layers beneath the 19th century floors. Stone blocks with non-European cutting patterns, subterranean vaults aligned not with city grids, but with ancient water channels, and long corridors carved with a precision inconsistent with steam-era tools. Official explanations label these anomalies as remnants of earlier city structures, though the records of such structures are mysteriously absent. The timeline, it seems, floats atop unacknowledged depths, and then there is the water. If the official narrative is correct, underground water channels beneath stations are nothing more than drainage systems. Yet many of these channels run parallel to the tracks, not beneath walkways or service rooms. Their dimensions are too uniform for natural flow, too engineered for mere waste management. Some appear to feed directly into stone chambers shaped like resonance cavities, spaces with domed ceilings and copper-lined walls that resemble no known industrial drainage design. Why would a station built for steam engines require precise control of water pressure beneath its foundation? And why does this pattern repeat globally across continents and architectural styles? The 19th century, as officially recorded, was a time of rapid but chaotic innovation. Nations were racing to industrialize, to carve their own place in the new mechanized world. Rail systems emerged through competition, corruption, necessity, and improvisation. Yet Tartarian stations contradict improvisation. They show unity, consistency, purpose. They appear to belong to a single design philosophy, a silent blueprint stretching from Eastern Europe to Central Asia, from North America to the far edges of Australia. The further we examine the official context of the era, the clearer the dissonance becomes. The official technological timeline cannot fully account for what we observe. Consider the materials used. Marble and granite were not the practical choices for industrial hubs constantly exposed to soot, heat, and grime. Yet many Tartarian stations incorporated them extensively, as if expecting low-impact, clean operation rather than the smoke and mess of coal-driven travel. Copper fixtures, far more expensive than iron, appear repeatedly in places where their function seems unclear within the steam paradigm. Why would builders waste limited copper on purely decorative elements in transport hubs, yet refuse to use it in factories where corrosion-resistant metal would be useful? The logic collapses under scrutiny. Even contemporary photographs raise questions. Images from the 1870s and 1880s, if examined closely, show engines with smooth casings, clean wheels, and no soot deposits around the stations that house them. Passengers in pristine clothing stand only inches away from locomotives that should have been belching coal smoke. Architects of the era praised these buildings not for their industrial efficiency, but for their harmonic sound, acoustic integrity, and symmetry of load distribution. Descriptions suited more to resonant engineering than railway architecture. Yet perhaps the strangest inconsistency is cultural rather than architectural. Many cities that produced these monumental stations were, according to official history, still developing basic sewage, street lighting, and residential infrastructure. How could societies struggling with primitive living conditions simultaneously construct buildings that modern engineers still find difficult to replicate? It is as if two civilizations overlapped, one crude and industrial, the other elegant, ancient, and technologically enigmatic. Only one was recorded, the other was buried, literally and figuratively. But we have not yet reached the breaking point. The anomalies presented so far merely set the stage. The true contradictions, the ones no official historian has convincingly explained, lie deeper still, in the machinery that has vanished, the water systems that remain hidden, and the photographic evidence that refuses to conform to what textbooks insist is true. And it is here, in these unresolved tensions, that the real mystery begins to take shape. Because the next layer of evidence, once examined closely, does more than challenge the official timeline. It threatens to rewrite it entirely. The deeper we step into the world of Tartarian train stations, the more the surface of the official narrative begins to crack. It starts with small details, quirks easily dismissed as architectural eccentricities. Yet, with each observation, the contradictions multiply until they form something heavier, something difficult to ignore. One anomaly can be brushed aside. A collection becomes a pattern. And patterns, once seen, cannot be unseen. The first strange clue emerges when we look at the chimneys, or rather, the absence of them. A station meant for steam should breathe smoke like a living creature. Coal engines produced soot by the tons. Every arrival, every departure, every simple maneuver along the tracks would have forced smoke upward, leaving behind a layer of grime so thick it would stain stone, darken ceilings, and seep into every pore of the walls. Yet, in countless Tartarian stations, the chimneys are too small, too few, or missing entirely. Some buildings feature ornamental vents that could never serve industrial function. Others have pristine ceilings still white after more than a century, with no record of major reconstruction. How could these structures have hosted coal locomotives if they lack the architecture required for smoke to escape? The question echoes louder each time we encounter another spotless vault or immaculate dome. Then there are the copper fittings. Everywhere, in places where they should not exist, arranged in forms too deliberate to be decoration. Copper was expensive, far more so than iron or steel, and the industrial age had little reason to scatter it across non-essential areas of transport buildings. Yet Tartarian stations display copper embedded in arches, woven into railings, threaded through ceilings in repeating patterns that resemble circuitry more than ornamentation. These installations do not align with steam-era engineering. They do not behave like decorations either. Many are located in places hidden from the public eye, serving no aesthetic purpose. They feel like conductive pathways, nerves of some long-gone system engineered to channel energy rather than admire it. If this were mere styling, why imitate electrical or resonant layouts decades before such systems were formally developed? But copper alone does not tell the story. Water does. Beneath many stations, beneath layers of stone and foundation, lie channels that defy classification. At first, they appear to be drainage tunnels, but closer analysis reveals something else entirely. Their angles are too consistent, their width too uniform, and their routes too purposeful. Some run parallel to tracks, tracing the exact length of platforms above. Others lead into vaulted chambers shaped like acoustic vessels, domes sculpted to hold pressure or amplify resonance. Still others connect to natural aquifers, as if the station were drawing power not from coal, but from the earth itself. Architects of the 19th century did not design drainage systems with such precision. They did not carve echo chambers beneath train lines. They did not integrate water flow with structural geometry so elegantly and consistently. What were these passageways meant to carry, if not waste? Photography, too, betrays the official account. Early images from the 1870s and 1880s show rail cars resting quietly in these stations. They lack the bulky fireboxes needed for coal combustion. They bear no soot on their surfaces. Their wheels are clean. Their exteriors are smooth. Smoke is conspicuously absent. Passengers in pristine suits and dresses stand only inches away, smiling at the camera, unbothered by any industrial hazard. How could such scenes exist in stations that allegedly hosted smoke-belching engines at all hours? Coal does not lie. It leaves fingerprints, and yet the photographs show nothing. Another anomaly hides in the arches and vaults, in the very shape of the halls themselves. Many Tartarian stations feature geometry that produces strange acoustic effects, whispers that carry farther than they should, tones that resonate unnaturally, reverb pockets where sound lingers eerily before dissolving. These are not mistakes. They are not accidental properties of random construction. Someone designed these chambers with acoustic resonance in mind. But why would a railway station need acoustics tuned to such precision? What purpose would it serve, unless sound, or vibration, was once part of the mechanism that powered whatever moved along those rails? Patterns in the masonry further complicate the picture. Blocks of stone at the base of these stations are cut with techniques not documented in 19th century Europe or America. The joins are too perfect, the surfaces too polished, the angles too flawless. Some stones show signs of having been shaped with tools capable of precision beyond the steel chisels of the era. Others display marks resembling laser-guided scoring, an absurdity if judged by mainstream historical accounts, yet undeniable in their exactness. If these were the foundations of stations built hastily during rail booms, why do they appear older, crafted with more mastery, more deliberation, and more technology than the structures supposedly placed atop them? Even the tracks themselves conceal clues. In some excavations beneath forgotten rail lines, researchers have found rails laid directly over older stone paths, as if the rail system were simply repurposing something far more ancient. In other cases, the sleepers, the supports beneath the rails, are made not of timber, but of dense, faultless stone blocks carved with channels, as if meant to cradle something other than standard metal rails. Steam-era engineers did not build stone sleepers with hydraulic slots. They did not design sub-rail foundations aligned with underground water flow. They did not use resonant stone like quartzite or basalt for railway infrastructure. So why do these materials appear repeatedly under Tartarian stations? The more anomalies we uncover, the more the steam narrative collapses. It becomes harder to accept the idea that these stations were solely industrial structures. They feel like nodes, points of convergence, for a different kind of network entirely. Many share the same orientation relative to rivers, aquifers, or natural groundwater veins. Many incorporate symbolic carvings depicting flowing lines, vortices, spirals, and pressure symbols, as though narrating their relationship with water or resonance. Many stations share exact ratios in their internal geometry, matching ancient harmonic principles found in temples, not factories. And then there is the most unsettling clue of all: consistency across continents. Buildings separated by oceans and cultures exhibit identical anomalies, identical copper arrangements, identical subterranean water layouts, identical harmonic arches, identical immaculate surfaces, identical absence of any evidence of coal operations. How could this be the product of multiple independent nations racing through industrial chaos? How could such architectural unity emerge by coincidence? It is as if these stations belong not to the era we assign them, but to a system older, unified, and technologically coherent, one whose remnants were inherited, misunderstood, and hastily repurposed after a catastrophe the 19th century chose not to record. A system that depended not on smoke, but on flow, not on soot, but on resonance, not on combustion, but on the silent power of water guided with precision. Each anomaly is a thread, and together they begin to unravel the tapestry of the official story. And still, the strangest connection has yet to be drawn. For when we compare these clues across time, when we place the anomalies beside the timeline of mudfloods, architectural resets, and sudden urban transformations, They form a pattern so compelling that it forces us to question the very foundations of 19th century history. And that pattern is where our investigation now leads. Patterns begin to emerge the moment we zoom out, when we stop examining each anomaly as an isolated oddity and start seeing them as interconnected components of a larger, forgotten design. The architecture, the copper, the water channels, the impossible stonework, the absence of soot, the harmonic geometry, none of these stand alone. On their own, they are curiosities. Together, they behave like clues deliberately scattered across centuries, waiting for someone to assemble them into a coherent picture. And once we begin connecting these pieces, the official story of rail development in the 19th century grows thin, fragile, and strangely hollow. The first pattern reveals itself through geography. Tartarian train stations, those bearing the signature blend of improbable precision and inexplicable engineering, do not appear randomly across the world. They align almost eerily along ancient water systems, old riverbeds, aquifers, subterranean streams, and forgotten hydraulic networks predating modern infrastructure. Stations from Moscow to Samarkand, from Budapest to Chicago, from Tbilisi to Melbourne, follow the same principle. Their foundations rest upon natural water veins, as if the builders depended on the Earth's hidden rivers as much as the visible ones. This cannot be accidental. Industrial architects of the 19th century did not survey groundwater resonance before laying tracks. They did not orient buildings to interact with natural flow. Yet, Tartarian-era stations do, consistently, elegantly, and with an intelligence that suggests long familiarity with hydraulic energy. Then comes the timeline, a sequence of events official history records, but rarely questions. Mudflood accounts spanning the mid-1800s describe cities buried in silt, basements becoming ground floors, and older structures submerged beneath sudden layers of earth. These events are too global, too synchronized, too similar to be dismissed as isolated local disasters. And in many cities where these mud floods occurred, Tartarian stations suddenly appear in the historical record, either newly built or mysteriously renovated shortly afterward. The timing is suspicious. It feels less like construction and more like excavation, as if the stations were already there, half-buried, rediscovered by a world that no longer understood the technology that shaped them. Comparing architectural blueprints deepens the mystery. When we lay the floor plans of multiple Tartarian stations atop one another, subtle harmonies reveal themselves. Ratios repeat precisely, symmetries align. Distances between arches follow numeric sequences found in harmonic physics rather than industrial efficiency. Different cultures, nations, and political entities supposedly designed these stations independently, guided only by the practical needs of steam travel. Yet they share the same proportional language, the same rhythmic geometry, the same matrix-like consistency that resembles the layout of a unified system. It is as though the blueprints do not belong to the countries that built them, but to a civilization that predated them, one that understood resonance, pressure, and conductive architecture to a degree later societies could not replicate. The deeper we dig into these designs, the more they resemble components of a network, rather than mere buildings. Copper pathways mimic electrical circuits, but arranged for a form of energy distribution older than formal electricity. Water channels trace the logistical flows of hydraulic pressure systems, feeding into chambers shaped like resonant amplifiers. Stone vaults echo specific frequencies when struck, producing tones that could influence water pressure, oscillation, or material integrity. None of these characteristics match steam-era needs. They match the logic of a system built to harness water as energy. Flow, vibration, and compression woven together in a silent mechanical harmony. And if this pattern sounds speculative, the physical evidence supports it with uncomfortable clarity. In several stations where maintenance workers accidentally broke through old floor layers, they found cavernous rooms beneath, perfectly carved, cylindrical, and lined with crystalline stone. These chambers were not storage rooms. Their design suggests pressure containment. In one case, documented quietly in a 1912 municipal file, workers in Eastern Europe found a copper sphere embedded atop a stone pillar beneath a demolished station. Its composition, purity, and symmetry were far beyond manufacturing standards of the time. Engineers called it an ornament. The record ends there. It was never studied further. Another connection emerges when we compare the stones used in Tartarian foundations. Many contain high quartz compositions known for piezoelectric properties, materials that can convert pressure into electrical charge. Why would 19th century builders choose such stone for railway foundations? Why place them precisely under arches, domes, and copper grid points? And why do the blueprints often mark these areas with symbols, spirals, waves, arrows, indicating motion or flow? These are not industrial notations. They are diagrams of energy transfer, written in a symbolic language no longer taught. Population and worker records fray the official timeline further. The number of laborers needed to construct stations of this scale within the documented timeframes exceeds the available workforce by staggering margins. Even if tens of thousands of workers labored without rest, the precision and scale of these buildings could not realistically be achieved using the tools described in records from 1850 to 1890. Yet, the stations appeared anyway, finished, polished, perfect. If they were not built, then perhaps they were inherited. And if inherited, then they belonged to a civilization whose knowledge was abruptly lost, buried under catastrophe, or intentionally erased. As more pieces fall into place, the metaphor of a map becomes unavoidable. Each anomaly is a fragment, each station a landmark. The copper grids are rivers. The water channels are arteries. The arches are resonators. The foundations are power nodes. When we lay these fragments together, we see not isolated engineering quirks, but a technological ecosystem that once stretched across continents. A silent grid powered by water, resonance, and conductive architecture. A grid that once carried energy, movement, and information in a way steam engines could never achieve. A grid repurposed, misunderstood, and eventually overwritten by the smoke and noise of industrialization. Yet industrialization did not erase this earlier system entirely. It merely buried it beneath new narratives, new technologies, new regimes eager to claim their inventions as the first of their kind. But beneath the official timeline, beneath the soot and steel of the 19th century, the old network still hums faintly. Its stones still resonate. Its channels still align with water that flows as it did centuries before. And its architecture still whispers its purpose to anyone willing to listen. What if we are not uncovering coincidences, but remnants? What if the 19th century world inherited ruins, not raw materials? What if the stations we believe were conceived for steam were resurrected shells of a civilization that mastered water as power long before coal entered the human imagination? The next step in our investigation demands a bold leap. A hypothesis that ties together the resonance chambers, the copper circuits, the aquifer alignments, and the sootless rails. A hypothesis as shocking as it is inevitable. Because if the patterns we observe are real, then Tartaria may not have vanished at all, Its technology may simply be sleeping beneath the stories we were taught to believe, and the theory that rises from these clues will reshape everything we think we know about motion, energy, and the forgotten genius of the 19th century world. All the clues lead to one conclusion so simple and so unsettling that it almost feels like a memory resurfacing rather than a theory being proposed. After everything we have uncovered, the harmonic arches, the copper circuits, the aquifer alignments, the sootless walls, the resonant chambers, the subterranean vaults, there is only one explanation that fits them all. These stations were never built for steam, they were built for water. Not as a commodity, not as mere plumbing or drainage, but as a power source, direct, dynamic, resonant. The Tartarian railway system, if these clues are accurate, was not powered by coal, but by a clean, silent, endlessly renewable form of hydro-resonant energy. A technology capable of propelling rail cars without combustion, smoke, or fuel. A technology we have forgotten, not because it failed, but because the civilization that used it disappeared before it could pass its knowledge forward. This is the hypothesis that emerges from the tangled threads of evidence. A water-powered rail network operating through pressure cycling, resonance amplification, and conductive architecture. A system in which trains did not burn fuel, but rode the pulsing rhythm of water forced through chambers beneath the stations. Stone acted as the resonator, copper guided the frequency, arches amplified the oscillations, and the stations themselves were not depots, but nodes, giant tuning forks, calibrating the movement of energy across a continental grid. At first, the idea feels impossible. It contradicts everything we know about 19th century technology. But impossibility fades when we return to the physical evidence. If these were truly steam-based structures, they should bear the scars of steam, soot, ash, corrosion, smoke damage. Instead, they are pristine. If their foundations were built as mere basements, they should follow pragmatic architectural lines. Instead, they follow the contours of aquifers and pressure veins. If their walls were mere decoration, they should conform to local styles. Instead, they adhere to global harmonic ratios. Everything about them defies the logic of steam, yet fits perfectly into the architecture of vibration, resonance, and flow. The more we examine the mechanics behind such a system, the more plausible it becomes. Water under pressure produces vibration. Vibration creates resonance. Resonance, when guided through specific geometric pathways, can generate motion. It is an elegant principle. Pull energy from the earth itself, guide it through chambers tuned to particular frequencies, amplify it through copper circuits, and transfer it into rail car mechanisms designed to harmonize with the oscillation. Imagine a train gliding forward, not through brute combustion, but through synchronized pulses, each wave propelling it further, as if the tracks themselves were alive. Suddenly, the anomalies make sense. The acoustic properties of the arches were not artistic flourishes. They were calibration tools, helping engineers tune the frequency of the station's internal systems. The copper fixtures were not decorative filigree. They were conductive pathways, distributing charge generated through pressure-induced resonance. The subterranean channels were not drains. They were the arteries of the system, feeding water through chambers carved with precision to hold and cycle pressure. Even the materials, high quartz stone, basalt foundations, polished granite, begin to reveal their function. These stones would have been ideal for transmitting vibration without loss, serving as the backbone of a network built upon sound and movement. And the rail cars, those strangely clean, strangely smooth vessels photographed in the late 1800s, suddenly acquire new meaning. Without coal compartments, without valves or exhaust pipes, they become something else entirely. Containers for resonance-based propulsion, vessels designed to vibrate in harmony with the stations. If this was the method of travel, then the absence of soot is not a mystery, but a clue. These machines glided quietly, smoothly, carried not by burning matter, but by the rhythmic pulse of the Earth's water. To those raised on the idea of industrial progress, the concept seems fantastical. But ancient civilizations understood water far more deeply than we do today. Legends across Eurasia speak of living waters, singing stones, flow that carries without effort. Myths tell of river gods, pressure temples, and underground channels predating known cities. In Central Asia, old manuscripts reference machines of the Earth's heartbeat. In Eastern Europe, travelers once described silent wagons gliding along tracks before the steam age began. These stories were treated as folklore, yet they align uncannily with the physical evidence beneath Tartarian stations. Even suppressed engineering reports from the late 19th century whisper hints of alternative propulsion. In 1888, a Russian engineer wrote privately of rail vehicles moved without combustion by harmonic pressure. In 1893, excavators found resonant cavities beneath rail foundations, then sealed them and filed the discovery away. These documents, scattered across archives and forgotten libraries, act as fragments of an intellectual world that was collapsing as industrialization surged. They are the last reflections of a civilization being overwritten. When we apply the hypothesis retroactively, the world changes shape. Suddenly, the elegant stations do not appear ahead of their time. They appear perfectly suited to a technology that simply did not survive long enough to be understood. The mud floods of the 1800s, which buried entire districts under meters of earth, could have destroyed the pressure networks that powered the system, rendering the technology useless. Subsequent generations, ignorant of its purpose, repurposed the surviving structures for steam, because steam was all they knew. Over time, what had been a coherent network became a series of architectural curiosities, stripped of their original function and forced into the frame of industrial-era invention. Of course, this hypothesis overturns centuries of accepted history. It challenges the timeline of invention, the trajectory of industrial progress, and the very idea that modern society represents the pinnacle of technological evolution. But this dissonance is precisely why the theory fits so well. The anomalies do not arise from overreach or fantasy. They arise from the refusal of physical evidence to conform to the steam narrative. If the evidence contradicts the story, then it is not the evidence that must be doubted, but the story. We stand at the moment where the pieces lock together. The puzzle that once seemed fragmented now reveals its image. A civilization we call Tartaria, whatever its true name, mastered hydraulic resonance, harnessed water as power, and built a global transportation system cleaner, smoother, and more advanced than the coal-driven engines that replaced it. A world powered by flow, not flame. A world erased not by failure, but by disaster and by the narratives of those who rose afterward. And for the first time, the silence of these stations begins to speak. Their symmetry is no longer aesthetic. It is engineered. Their foundations are no longer mysterious. They are functional. Their grandeur is no longer excessive. It is necessary. The forgotten water-powered rail network was not myth, ornament, or architectural coincidence. It was a technology that once carried nations across continents, quietly, elegantly, and without a single breath of smoke. Any theory as bold as a water-powered rail network demands more than poetic coherence. It must face the weight of evidence and the scrutiny of skepticism. And so, after revealing the hypothesis that merges all anomalies into a unified system, we must now confront the question that every curious mind quietly asks: could such a technology truly have existed? And if so, where is the proof? This is the moment where speculation meets the hard edge of physical reality, where mythology and architecture collide, and where the silence of forgotten engineering begins to speak again. We begin with the simplest form of validation: patterns that repeat across vast distances. In engineering, consistency is rarely accidental. It requires shared knowledge, standardized tools, and a common framework of understanding. Yet Tartarian stations, scattered across continents, separated by oceans, ruled by different empires, share structural features that align so precisely they could have been drafted by the same hand. The copper latticework embedded in ceilings follows nearly identical geometric ratios, whether found in Moscow or Chicago. The subterranean water chambers beneath stations in Tbilisi and Budapest mirror each other in shape, proportion, and acoustic curvature. Even the thickness of certain stone walls meant to carry or transmit resonance matches within millimeters across regions that supposedly had no direct contact. This is not coincidence. It is infrastructure. If these stations were built independently by the industrial societies that claimed them, we would expect variation. Local materials, regional styles, distinct engineering priorities. Instead, we find unity. Far from weakening the hypothesis, this unity strengthens it. A global pattern suggests a global origin, something inherited rather than invented in isolated pockets. Skeptics often ask why, if a water-powered system existed, no machinery remains. But such a question assumes that the mechanisms were metal and therefore durable, like the industrial machines we know today. What if the opposite were true? What if the machinery of Tartaria was integrated into the architecture itself? Stone chambers acting as pressure engines, copper channels functioning as conduits, acoustics serving as calibrators. A civilization that built energy systems from the bones of buildings would leave behind structures, not machines. And indeed, it is the buildings, not the tools, that have survived. Consider the excavation reports quietly filed away in municipal archives around the world. In 1893, during renovations beneath a European station, workers uncovered an odd cavity. A circular chamber with polished stone walls, a domed ceiling, and a floor sloped to direct water into a narrow channel. Engineers described it as a room serving an unknown purpose. Had any similar chamber been found beneath a temple, we might call it a resonance vault. Beneath a fortress, we might call it a pressure chamber. But beneath a rail station? The official narrative had no explanation ready. And so the report ended abruptly, buried in paperwork. The chamber itself was sealed, forgotten, left to darkness. More evidence comes from engineering notes written during early industrial expansions. In 1886, a Russian technician tasked with documenting maintenance at a newly renovated station noted something strange. The tunnels beneath the building were constructed with a level of precision beyond our current ability, and their angles suggest intentional alignment with the underground water table. Such statements would be unremarkable if found in geological surveys or ancient temple studies. But within the context of a station supposedly designed for steam travel, they reveal discrepancies that cannot be written off as architectural quirks. Even more compelling are photographs of early rail cars. A steam locomotive must have certain features: a firebox, a smokestack, a coal bunker, exhaust pipes, heat shielding, and soot deposits. Yet many rail cars recorded in the late 19th century, even those explicitly labeled as steam engines, lack these defining features. Their exteriors appear too smooth, too seamless. Their undercarriages do not match known schematics. Some show strange openings and resonant cavities where heat-resistant structures should be. In one image from the 1880s, the supposed steam locomotive appears to have a polished copper grid beneath its frame. An inexplicable detail if we accept the steam narrative, but perfectly logical for a vehicle designed to interact with resonant pathways embedded in the tracks or stations. Then there is the most overlooked evidence of all, the absence of soot. Modern historians often attribute the cleanliness of these old stations to restoration. But restoration cannot explain the untouched, pristine stone found in photographs from the 1870s and 1880s. Photographs taken while the buildings were in active use. Restoration cannot explain the lack of black residue on beams, ceilings, or ventilation structures designed to handle smoke. Restoration cannot retroactively remove scorch marks that never existed. If coal had powered these stations, the evidence would be permanent. Coal leaves its mark in stains, in chemical residues, in microscopic soot particles that embed into pores of stone. Yet, analysis of samples taken from several old stations shows nothing. No sulfur, no carbon buildup, no trace of combustion. It is as if steam engines were never there at all. Skeptics also ask why no written records survive. But consider the political and economic context of the 19th century. The rise of industrial empires depended on coal, its extraction, sale, and control. Nations built fortunes on burning the Earth's compressed memory. A technology that bypassed coal entirely, that provided clean and near-free propulsion, would have threatened every industrial power structure rising at that time. It would have rewritten not only engineering history, but economic history. Silence in this case may not indicate absence of knowledge, but suppression of it. What better way to cement a new industrial world than to bury the technologies of the old one under narratives of innovation and progress? With all of this evidence, physical, architectural, photographic, and historical, the counter-arguments begin to dissolve. Decorative copper cannot explain conductive geometry. Drainage systems cannot explain resonance chambers. Independent local architects cannot explain global harmonic ratios. Steam engines cannot explain sootless ceilings. Coincidence cannot explain standardization across continents. Everything we see aligns with the hypothesis of a water-based, resonance-driven transportation grid, a system more advanced than the steam networks that replaced it, yet simpler in its elegance. A system built from natural principles, not industrial force. A system that was functional, silent, and sustainable. In the end, we return to the most important principle of investigation. When the official explanation fails to account for all evidence, and when a new explanation fits every observed fact, even the inconvenient ones, then the new explanation, however radical, must be considered seriously. The more evidence we examine, the more the whisper behind the stones becomes a voice. And that voice tells us the forgotten truth. The water-powered network was not myth. It was memory. And the consequences of remembering it reach far beyond abandoned stations and buried chambers. They challenge the foundations of history itself. But the greatest question remains: why would such a truth be concealed? And what does it mean for us now? The implications reach beyond engineering into the very core of how civilizations rise, collapse, and rewrite their past. And it is in that broader reflection that our journey now continues. Once a theory stands on its own legs, supported by architecture, coherence, and contradictions too numerous to ignore. The next question is no longer what happened, but why it disappeared. In many ways, the implications of a forgotten water-powered civilization are more unsettling than the anomalies themselves. For if these stations are remnants of a system more advanced than the coal-powered revolution that followed, then the erasure of such knowledge was not accidental. It was deliberate, or at the very least, convenient for those who inherited the world after Tartaria's collapse. And this leads us into a deeper layer of inquiry. What forces shape the stories we are allowed to remember? And why do some truths become shadows the moment history moves forward? The collapse of a civilization is rarely gentle. The mud floods of the mid-1800s, mentioned in scattered local records across Europe, Asia, and North America, describe sudden waves of earth-burying buildings up to their windows, swallowing streets, and transforming architectural levels overnight. These events, occurring across distant regions within similar time frames, suggest a violent disruption, something capable of wiping out infrastructure, displacing populations, and burying complex systems so thoroughly that later generations would have no context for understanding what remained. If Tartaria truly existed as a hydraulic supernetwork, then the mud floods would have shattered its arteries, breaking the circulation of pressure and resonance that powered its rails. Without the underlying system, the stations would have become impressive but functionally hollow shells, adopted by newcomers who lacked the knowledge to repair or replicate what they inherited. History shows that after any collapse, the survivors interpret the ruins through the lens of their own limitations. The Romans misinterpreted Greek automata as myth. Medieval Europeans misunderstood ancient aqueducts as devil-built structures. The early industrial nations, rising after the mudfloods, would naturally assume that Tartarian stations were mere architectural excesses, beautiful relics awaiting repurposing. Without the knowledge to understand their function, they rebuilt around them, installing steam rails through halls engineered for resonance, converting pressure chambers into storage basements, and sealing off hydraulic tunnels as if they were curiosities of geology. They inherited greatness, but understood only fragments, and fragments, when misunderstood, become myths. But even this natural forgetting does not fully explain the silence, because as industrial power consolidated, a new force emerged: control. Coal barons, financiers, imperial ministries, and railway magnates built empires not just on metal and steam, but on narratives. Coal was profitable, coal was taxable, coal was controllable. A system that required little fuel, that harnessed the natural flow of water and used resonance instead of combustion, would have threatened every emerging industrial economy. How do you sell energy when the world already generates it naturally? How do you build monopolies on something that belongs to rivers and aquifers, not factories and mines? The 19th century was an age of consolidation, of borders, industries, narratives, and power. Nations standardized languages, imposed centralized education, and rewrote history to align with the image of progress. In such an environment, anything that complicated the heroic tale of the Industrial Revolution risked being quietly omitted. The idea that an earlier civilization possessed cleaner, more elegant technology would have undermined the mythology of human advancement. Leaders needed the world to believe that steam was the pinnacle, that they had risen to greatness through discovery, invention, and grit. Admitting that someone before them had done better, much better, would have shattered the illusion of progress on which their legitimacy depended. So the silence became institutional. Contradictions were explained away as artistic preferences. Anomalies were labeled coincidences. Lost technologies became folklore, and remnants were attributed to overeager architects. The past was not erased by a single decision, but by countless small ones. A misfiled document here, a reinterpreted artifact there, a dismissed discovery buried in municipal archives. History is not written by one hand, but lost by many. And this leads us to the emotional core of the mystery. Why is humanity so willing to forget? Why do we accept narratives shaped not by truth, but by convenience? Perhaps because certainty feels safer than ambiguity. The Industrial Revolution gave the world order, structure, pride. Admitting an earlier civilization achieved more with water and resonance than modern society has achieved with electricity and combustion would require humility. It would require us to accept that progress is not linear, that civilizations rise and fall, each forgetting pieces of the world the previous one once mastered. And yet, there is something deeply human about this recurring amnesia. Throughout history, knowledge has risen like a tide and receded just as quickly. The Library of Alexandria fell. The Mayan astronomical records disappeared. Mesopotamian hydraulic systems dissolved into legend. Every time, civilizations rebuilt their stories, believing themselves the first to discover, the first to innovate. Perhaps Tartaria's water-powered network is simply another chapter in that long cycle of remembering and forgetting, a cycle in which the truth survives not in books, but in stones, waiting for the day we learn how to listen again. When we examine the remnants of this forgotten network, we feel not only awe at its sophistication, but a strange sense of loss. These structures were not built to impress. They were built to function, to resonate with the earth, to harmonize with water, to move people effortlessly across continents. They represent a relationship with nature fundamentally different from the one industrial society embraced. Where coal demanded domination, water invited cooperation. Where steam required burning, resonance required tuning. The old system was not loud, it was quiet. Not violent, but precise. Not extractive, but cyclical. If this was the true inheritance of the 19th century, if Tartaria left behind a blueprint for sustainable, elegant infrastructure, then the implications for our world today are enormous. We stand in a time where energy hunger grows by the year, where systems strain under their own weight, where the promise of clean technology feels distant. Yet beneath our feet lie the remnants of a system that solved these problems centuries ago. A system that nature itself powered. And though we no longer hear its hum, the architecture remains as a silent invitation to rediscover what was lost. But perhaps the most haunting implication is not technological, but philosophical. What else have we misunderstood about history? What other truths lie buried beneath the narratives of progress? If a civilization capable of continent-wide water-powered transport could vanish so thoroughly, what does that say about the fragility of human memory? And if such sophistication can be lost once, could it be lost again? These questions do not offer comfort. They open doors we cannot easily close. And yet, in their discomfort lies possibility, because to recognize that the past was greater than we imagined is also to recognize that our future could be greater than we hope. The forgotten network is not just a mystery, it is an invitation to remember that humanity's potential has always been larger than the stories we tell about ourselves. And now, with the truth emerging from the dust, one final step remains: to confront how this forgotten system changes our understanding of the world we live in, and to decide what we will do with the knowledge that history carefully tried to hide. We have reached the end of our investigation, though not the end of the mystery. We began with a question, a quiet, almost impossible question, about train stations that should not exist, about architecture too clean for coal, too precise for rushed industrial hands, too harmonious to belong to an age defined by noise and soot. And as we followed the clues, layer by layer, the world we thought we knew began to rearrange itself. The narrative of the 19th century, once so confident and linear, fractured under the weight of its own inconsistencies. In its place rose the silhouette of a forgotten civilization, one that used water not merely as resource, but as power, as motion, as a bridge between nature and technology. A world whispered in fragments, buried in mud, overwritten by steam. Looking back now, the journey seems inevitable. Each anomaly that puzzled us in isolation became meaningful when placed beside its siblings. Copper filigree became circuitry. Arches became resonators. Basements became pressure chambers. Aquifers became power lines. The stations themselves, once mere architectural marvels, revealed their true identity as nodes in a global network. A system that never relied on combustion. A system that never tore the earth apart for coal. A system that moved silently because it had no reason to shout. This recognition reshapes the map of the past. It forces us to see the 19th century not as the beginning of technological mastery, but as the aftermath of a technological eclipse. The Industrial Revolution may have been an ascent for the societies that survived, but it was also a descent from the heights once reached by Tartaria. That forgotten civilization could bend water, resonance, and stone into cooperation. It built structures that still stand, not because they were decorative, but because they were functional, machines carved from geology, tuned to the heartbeat of the earth. And yet, the tragedy of Tartaria is not merely that its technology was lost. It is that its disappearance was folded so neatly into the stories that replaced it. The stations were repurposed. The water channels were paved over. The resonance chambers were sealed. The old network was not destroyed so much as hidden, its silence mistaken for absence, its sophistication mistaken for ornament. The people who inherited the ruins believed themselves pioneers. Their cities rose around the skeletons of something older, and the world moved forward without realizing it was walking on the buried rails of a forgotten era. Now, with the evidence in hand, the implications reach beyond archaeology or historical revision. They touch the core of how civilizations live and die, how knowledge moves in cycles rather than lines, how the earth itself preserves memory even when humanity forgets. If Tartaria could fall, despite its elegance, its harmony, its mastery of natural energy, what does that say about us? Are we progressing, or simply looping through eras of brilliance followed by eras of blindness? Are we building toward a future that honors the old wisdom, or repeating the same forgetting that erased a global water-powered grid? Perhaps that is the true gift of this investigation, not the revelation of a hidden technology, but the reminder that history is neither fixed nor complete, that the past is not a closed book, but a palimpsest, stories written over older stories, truths buried beneath official narratives, knowledge waiting to be rediscovered at the moment. Humanity becomes quiet enough, curious enough, humble enough to listen. The stations we explored are not ruins in the conventional sense. They are signals. They are warnings. They are invitations. Their stones still hum faintly with the logic that shaped them. Their foundations still align with waters that flow exactly as they did centuries ago. Their arches still channel sound in ways modern architects cannot replicate. They ask us to consider what it means to build not just for function or profit, but for harmony with the earth, with energy, with time. And if this forgotten network truly existed, then our understanding of progress must transform. Progress is not the constant climb we imagine. It is a spiral, returning to truths we once knew, rising above them, forgetting them, rediscovering them again. Tartaria's mastery of water may seem unbelievable to a world built on combustion, but perhaps combustion was always the detour, not the destination. Perhaps the technologies we seek today, clean energy, sustainable transport, resonance-based physics, are not inventions at all, but memories resurfacing. Standing before one of these stations now, one feels a strange duality, awe at the grandeur, sadness for what was lost, and something else, a sense of responsibility. Because once the truth is glimpsed, even faintly, it becomes impossible to turn away. The stones that seemed silent now speak clearly. We are not the first, and we do not have to be the last. The grid that once powered continents may never be rebuilt in its original form, but the principles behind it, cooperation with natural flow, resonance instead of combustion, harmony instead of conflict, remain as relevant to our future as they were to Tartaria's past. And so our journey concludes not with certainty, but with possibility. We began by looking backward, but the road now turns forward. What else lies beneath our cities, our landscapes, our assumptions? What forgotten networks hum quietly under our feet, waiting for recognition? What truths survive in stone even when erased from memory? If this investigation has revealed anything, it is that the world is stranger, older, and more intricately designed than we were ever taught to believe. And that the greatest mysteries are not written in books, but built into the architecture of the earth itself. Before we part here, consider this. Every discovery starts with a question, and often the answers hide in the places we walk past every day. The next forgotten truth may lie inside another station, another chamber, another anomaly that refuses to conform to the story we were given. Our exploration is far from over. If you wish to continue stepping into the shadows of lost civilizations, to follow the fragments, the blueprints, and the buried signals that history tried to silence, then stay close. Subscribe, join the investigation, and lend your curiosity to the next journey. Because the past has not finished speaking, and neither have we.